I thought now would be time for a small video on step and ramp functions and then how we put that into convolution. And just to refresh our memories, the unit step function ut equals 0 when t is less than 0. So we have that. And it equals 1 when t is greater than or equal to 0. So we have this discontinuous step of infinite slope between 0 and 1. The ramp function, on the other hand, you have a slope of 1 versus time, right, for when t is greater than or equal to 0. But in a similar vein, it's 0 before time equals 0. Now, what we're going to do, or what we often do, is let's say we want to do the convolution of a ramp times a step, right? And that would be RT convolution symbol UT. So there's the convolution integral for the time domain. And then the first thing we do is we do a substitution for what RT is. And I'll write it here first. Okay. And I'll put tau u tau, and then I'll finish out the rest of the convolution integral. Now, this might seem confusing, right? How can I substitute this when that was the definition of the ramp function? However, if we just do some plotting, we realize that RT is a composite function of time and a step function. So let's just draw these things out. Here's time. So what is t, right? We're saying the first function is t. We'll pick a nice, pretty color for t. Right? That's t. The slope is 1. Right? That's t. Slope is 1. The difference being it's 0 for less than time equals less than 0. Right? How do we get this in function format? Right, in a nice compact way of saying it, rather than that definition to be 0 and then t. Well, let's just draw our step function. All right, and we're going to multiply these two. And other things we've added it, but this is just a straight multiplication of these two curves. So we multiply 0 times anything, it's going to be 0. Right? Now, it's 1 times something. 1 times something is something. And so we get the t. How do we write that out? Right? RT equals t ut. So this is just one of those things, back and forth that we have to remember, right? And then as a bonus for today, what if we had a delay or a time? I'm just going to add a time shift, right? That would equal t plus t times u plus that time shift. Okay, you have to substitute in the whole whole time. So anyway, now that you have this, right, and you know that this functions will be 0 when time is less than 0, right, you just, those are 1, right? But how do we enforce this so that the UTs are always 1? You change the lower limit to 0. So if it's 0 onwards, we're always in this range. And so we just set those UTs, and that's where we get that 0 T tau d tau, which turns into t squared divided by 2, which will become a ramp divided by 2. Anyway, I hope this video finds you just in time when you needed it.